All right, we're moving on to chapter 6, lesson 6, and I need a highlighter. There we go. We are working with rational and irrational roots. So let's remind ourselves what a rational number is. A rational number is numbers or fractions and decimals that terminate and repeat. For example, 1/2 terminates to be 0.5. That's a rational number. 1/3 repeats to be 0.3 repeating. An irrational number is one that does not terminate and repeat. So if I was to put the square root of 11 in my calculator, let me do that really quickly. The square root of 11 is 3.316624. Yeah, that one does not terminate or repeat. Pi, if you know what pi is, that does not terminate or repeat. That's 22/7, which is 3.142857143, etc., etc. So the first thing says to write as a finite or a repeating decimal. Remember, in order to do this, I can go ahead and just divide the denominator into the numerator. Well, that doesn't work. So I need to add a bunch of zeros, correct? Yeah. So let's go ahead and start dividing. I know that we have to put this up here. Wow, I'm running out of room already. And 80 does not go into 17, but it does go into 172 times, which gives us 160. And when I subtract, I get 100. 80 goes into 100 one time. And I subtract and get 20. I'm trying to think, I brought this one down here, this one down here, this one down here. Does 80 go into 200? Yes. It goes 2 times to give us 160. I need more room. And 80 goes into, looks like I need to add a 0. 400, voila, we're finally stopping 5 times. And that's good old elementary math, right? I think you guys do that in 4th or 5th grade, probably 5th grade, decimals. So the answer here is 0.2125. And we know this is a terminating decimal, and this is a rational number. All right, moving on, I'm going to let you guys figure out 13 divided by 33, so push pause and take the time to figure that out. All right, so when you divide 13 by 33, so remember we're taking 33 and dividing it into 13.00, I think you had to add 4 zeros as well. It looks like you end up getting 0.3939. So it looks like this 0.39 is being repeated. So this is another rational number. Since we're just working with common fractions today, what do I do if I have All right, now it looks like we have a problem. Notice I have a repeating number. Sorry, I'm trying to figure this out. This vinculum shows me that it's repeating. So I can't just take tens, hundreds, thousands and put 348 over 1,000 to solve this. So there is a little trick that I have to solve this, okay? So let's go ahead and learn this trick. I'm going to show you with a different number first to make sure that you understand it, and then I'm going to show you with this one. So let's go over here and let's look at another question. So if I was to have let's do 0.045 with only the 5 repeating. So we're going to look at these numbers right here after the decimal point, and that's going to be underneath in our denominator. So we're going to put those right here. Any number that is represented with a repeating, the repeaters are going to be represented by 9s, and we have to put those in the front. And then all the non-repeaters, so for example the 0 and 4, have to be represented with zeros. So I have 3 numbers here, 1, 2, 3, and I'm going to put 3 numbers in the denominator. Now I'm going to take the whole number, so the whole number is 45, okay? I'm going to ignore this decimal, and I'm going to take the whole number, and I'm going to subtract the non repeating part. So I'm taking the whole number disregarding the decimal point. So I'm taking 45 and I'm subtracting 4. Well, 45 minus 4 is 41, and I'm putting this on top. Now, if I didn't have a calculator, I would have to reduce here. Okay, in this case, this one can't be reduced, so I don't have to worry about this one. This one's actually very user-friendly. So, but sometimes you'll have like 200 over 900, and you have to reduce. Let's look at another one. Okay, 0.83. Oops, I forgot a 0. 0.083, where only the 3 is being repeated. So remember in the denominator, because I have one repeating section, that's going to be a 9. The 2 that aren't are going to be represented by zeros. I'm going to take the whole number 83, and I'm going to subtract the part that's not repeating, and that's 8. Well, if I take 83 and I subtract 8, I get 75. Well, I know 75 and 900 could both be reduced by 25, right? Yeah, I think I could divide these each by 25. And it looks like my answer is 3 over 36. Oh, that can continue to reduce, 1/12. So let's just take in our calculator. I'm assuming we don't have calculators. Remember, some tests and quizzes we have calculators, some parts we don't. So if I take my calculator and I take 1 divided by 12, I do get 0.083 repeating, which was my question. So let's go back to this weird question from the book. Notice in the denominator, we are going to have all 9s. 1, 2, 3, because they're all being repeated. And then you're going to say, well, what happens when there's no non-repeaters? So I'm going to take the whole number. And if I subtract no non-repeaters, isn't this just 348 over 999? Good. Both of these can be divided by 3, so when I reduce, I do have 116 over 333. And again, I'm going to go ahead and check this. If I take 116 and divide it by 333, voila, I get 348, 348, 348, which is 348 repeating. So let's go ahead and look at example 4. Example 4 says find a rational number r and an irrational number s between 1/5 and 1/4. So I know that 1/5 is what number? Good. I know this is approximately 0.2 or 0.20. And I know that 1/4 is 0.25. So wouldn't the easiest thing to do is to find a number between these two numbers? So 0.21 would work, 0.22 would work. But if they're asking as a fraction, would I need to solve as a fraction? Probably. So I would probably take this 0.22 and put it over tens, hundreds. 22 over 100. And 22 over 100 could all be reduced. And, well, that's just 0.22, but they could reduce by 2, so we get 11 over 50. All right, the last part is just seeing if things are rational or irrational. So I'm going to give you a second to push pause. You know what, let's just do this section first, and let's see if things are rational or irrational. Now, it's really easy with a calculator, but let's assume you don't have a calculator. What would you do? So let's go ahead and take a second to push pause. All right. Well, I know that the cubed root of 16 is an irrational number. Hopefully you have this one memorized. The cube root of 27 is 3, so that's a rational number. I told you that anything with pi is going to be irrational. And what about this weird number, 7.23 over 3.14? That is a rational number. Last section. Write as a decimal. Actually, we have 2 more sections. Do you guys know the trick for 1/8? So if you look on a calculator, and if I was to take 1 divided by 8, we get 0.125. Well, I know 2 divided by 8 is 1/4, right? Well, 1/4 is 0.25. Now I'm going to write a 0 here for repetition and pattern's sake. 3/8. Well, again, if you kind of start noticing the pattern, this is 0.125. This is an additional 0.125. So if I added another 0.125, and 3 divided by 8 is 0.375, which makes sense because 4 divided by 8 is 0.5 or 0.500. So notice everything's kind of going up, and it's always good to notice patterns in math because that's what math is coming from, all these patterns together. So looking at this one, 5/8 is 0.625. Anything over 11? Do you guys know the pattern for 11? It's kind of like the 9s pattern. This is going to be 0.45 repeating. So I think about those 9s that make up, they add together to be 9, so 36, 45. I think about that. So 1 less than the 5 is 45, and that's going to be repeated. Now 5 divided by 6 and 5 divided by 7, I don't have anything fancy for you. I apologize. 5 divided by 7 is 0.714285. That one goes on. That one's an irrational number. All right. The last thing I'm going to have you guys take a minute, pause your video, and write these as a common fraction. 0.8 repeating. Hopefully you've learned now that anything over 9 is itself repeating. So like 4/9 is 0.4 repeating. 2/9 is 0.2 repeating. Hey, that makes sense. Whoops, I forgot my repeating. And 3/9, that's 1/3, right? Isn't that just 0.3 repeating? Nice. 0.08 reduces down to 2/25. And the last two that we're going to do today, 0.08 repeating is 8/99, and 0.08, just the 8 repeating, is different. It's going to be 4/45 when you reduce it. So you can use that trick, that repeater trick that I showed you in the beginning.